Hello and welcome to this video on vectors and scalars. This is usually a key component at the start of a physics course, and so hopefully this will get you completely conversant with vectors and scalars and ready to go. So to start with, defining a scalar. Okay, a scalar quantity is one where it's fully described by what's known as its magnitude. Magnitude basically means size. Okay, so for example, the time an object happens to do something, say it was 220 seconds, okay, this here is its magnitude. Okay, obviously we have to have a unit as well. Okay, but that is a fully described scalar. Okay, which means that a scalar is a quantity fully described by its magnitude. Okay, now the one that's more complicated is vectors. Okay, there's a lot more involved in vectors because vectors are not fully described by their magnitude. Sorry, I'm just making this look really neat. So, vectors are not fully described by their magnitude. They have to have one extra thing to them, and that is a direction. So, for example, if we had a value for force, okay, and we said it was 35 newtons downwards. Okay, now we have the magnitude still, but we also have this extra part here, which is the direction that is acting. Okay, and again, please note, I'm going to hammer this in, you need to remember your unit. Okay, so a vector, okay, is a quantity which is described by having a magnitude and direction. Okay, so let's have a few examples of each of these then. So if we have some examples of scalars, we could have mass, distance, energy, time, speed, power. Just a few examples. Okay, and some examples of scalars as well. We have velocity, displacement, impulse, momentum, force, and weight. Okay, these are just some examples of vectors and scalars. Okay, now the definition of this is extremely important. It's a common 1-mark question from exam papers. But so we're going to have a look at adding some vectors. Okay, now it's really important to consider the difference between distance and displacement. We said before that distance was a scalar, so it didn't have a direction added to it, but displacement was a vector, so it has distance. Okay, so we have a scalar, a vector. So looking at this example, okay, the first thing I'm going to do is we have a boy who walks 3 meters to the west. Okay, so that means he is going to go 3 meters this way. He's then going to come back and walk 2 meters east. Okay, now that would be the 2 vectors that he walked. Okay, now for part A we have to work out the total distance he walked. Now distance is a scalar, so doesn't take into consideration the distances that the different directions that he walked. It only takes into consideration the magnitude of it. So what we can say is that the distance he walked here is 5 meters. Okay, fully represented by its magnitude. 5 meters from start to finish. However, his displacement takes into consideration the direction that he walked. So if he walks 3 meters east and 2 meters back, 3 meters west and then 2 meters back east, he's actually only 1 meter from the starting point. Okay? And because we're taking into account these distances and displacement calculates including the distance, we're actually only having a displacement here of 1 meter. Okay, so displacement is the distance you are from your starting point, how far you are displaced, right? Now this is a really simple one because it's straight backwards and forwards, okay? But there will be further examples in another video where we're going to look at solving vectors at right angles. If you like this video and subscribe for more videos and see the next one on right angled vectors. Enjoy.